Welcome to ECE 275, lab number one. This lab is about designing and verifying a logic circuit, and my name is Bowden Ingram. The objective of this lab is to design a logic circuit using Chorus software and to simulate that circuit and verify it through using Model Sim. Here's the truth table that was provided to me by my professor. This is demonstrating an XOR truth table. Basically, when one of the signals is true, output is true. But when both signals are false or true, output is false. So only one can be true. And here's a schematic that was designed by me for the lab. Let me move my camera down here. And I apologize for my face is going to get really pale. My camera settings are a little wacky. So let's say so this is a XOR schematic. We are going to be demonstrating here with the drawing tool. So I'm just going to explain some of the things. So we got our inputs on the left, X1 and X2, and our output on the right, F. This is a NOT gate. It reverses the signal given to us, or the 1 or 0 that is given to us. And an AND gate accepts values that are the same, and an OR gate accepts one value that is true. So let's start. Let's go with inputs from X1 being a 1 or true, and X2 being 0. So first, our input X1 is going to go through our NOT gate and be flipped or converted into a 0. And that 0 is going to be I'm going to put it here to show that it's going into this AND gate. And our X2 is also, the 0 is going to fall over here and be here. But that 0 is also going to go through its own NOT gate up this path and get flipped into a 1. And as you can see here, the 1 up here is going to get saved. So 1 right next to this AND gate. And like I said at the start, the AND gate is accepting two values that are the same. So this is a true and a true. The AND gate is looking for true and true. That's true. False. It's looking for false, false. That is true. And then our OR gate is looking for just one true. And it's gonna get a 1 here and a 1 here. Both of those are true. Let's our output be one true. Now let's say both of our inputs are true. Let's start with 1, 1. 1 is going to get saved. 1 here. This 1 is going to get saved. 1 here. It's going to go through its NOT gate, get turned into 0. This one's going to go through its NOT gate, get turned into 0. These zeros are going to be here. We got a 0 and a 1, 0, 1. So this is a true and a false, false and a true. And like I said, we got a false and a true, and it's AND gate. That's false. False and a true. AND gate is looking for two of the same. That is false. The OR gate is looking for simply one true. We got a 0 and a 0. That's false, which our output is now false or 0. So that's the demonstration of the XOR schematic and shows you how both only one signal can have the truth. And even if we have two zeros, it will have the same effect. 0, 0. I'm just going to go by this fast. 0, 0, 1, 1, 1, 1. False, true, true, false, 0, 0. Output 0. Okay. Okay, so here's my model simulation setup. So what are we looking at here? Well, first I have the truth table here just so we can remember and verify what is going on here. And I just want you to be able to think about this as this first line here is X1, and we're running this through 1,000 picoseconds. Second one here is X2, also running through 1,000 picoseconds. And our output, this is our output right here. This bottom line is our output running through 1,000 picoseconds. Now, let's look at this one line here, this yellow line here. You can see that it goes up, up, down, up. But right now, it's sitting right here at this down part, and the down part of X1 and the up part of x2. Now, down is going to be 0, up is going to be 1, and that's a 0 and a 1 for x1 0, x2 1. What did we learn in the last schematic? That produces a 1 for our output. And you can see here it goes up for the 1, and our output is 1. Now let's go look at, we can look at any here. Sadly, I can even pull up, I believe. Let's pull it up right here. So here is my thing. We can run it through. Now let's look for one where we have two ups. We got two ups right here. Two ups. That's one, one. And look at that. F is 0. The output is 0. Let's even look at the back here. We got up and a down, an up and a down. We got 1, 0, and 1. Let's look for a down, down. We got down, down, 0, 0, 0, 0, 0. That's our output. Okay, so as you can see that basically our signal here up, high, 1, low, 0. And these line up with our truth table that was provided to me by my professor. And I want to talk about my own reflection in this lab. I had my own struggles when coming up with some of this stuff. My files didn't save. I had some trouble with loading stuff up and designing and not paying close enough steps. I at first I went through and I got to the point in this lab where I thought I was going to need a circuit board. Turns out I don't. That stressed me out a little bit. So if I wanted to talk to anybody else doing this lab, I would say, really pay attention to those tutorials that were given to you. They really go in depth and read every part. Don't just look at the pictures and stuff because I almost thought I was going to have to do this lab over again. And when I attempted to do this lab over again for the video, I couldn't even get the thing to start and it kept not responding. And I was freaking out. And, just keep calm and save things in files. It really helped me explore through my file explorer. I've never had to dig through because I didn't put it in the right spot. I didn't do that. And, I think I really learned to be reflective of my own like organization. I thought I was a good organized person, and turns out I can be even more organized. And being organized and getting a file put in the right spot was very helpful during this lab. And I just thank anybody that will see this, and I hope my professor sees this, and I hope that it is well enough for you. Thank you.